Section 2.3 is a whole lot more lines. We'll start with linear models, which we talked about a little bit in class, bringing you your y equals mx plus b form, right? We talked about this last class. This is called slope-intercept form. Slope because m is your slope, and intercept because intercept is given by your b value, the y-intercept for the line. So you're already pretty familiar with this form, but let's do an example of a linear model. So if we have a train that's traveling at a constant speed starting 5 miles outside of Albuquerque that is ending in Colorado Springs 5.5 hours later, determine a linear model for the distance from the train to Albuquerque, right? Our slope is our rate of change, so we know that this particular train is going to end 380 miles away from Albuquerque, and it starts 5 miles outside of Albuquerque. So the changes in y values, or the change in the distance, because that's what we're trying to find a function of, right? Find a linear model for the distance from the train to Albuquerque. So that's our output. Thus, the only other thing we have is time, and so that'll be our input, right? That's where the hours comes from, is time. And so if I look at the difference in my y values, the 380 minus 5 goes on top, and then 5.5 hours minus a 0 is in there, right? Because you're assuming that the start is at 0, time-wise. So the slope, it will be given by 380 miles minus 5 miles over 5.5 hours minus 0 hours. Okay, and that corresponds to what? Since that's our rate of change, that is our m in y equals mx plus b. So that gets us 375 miles over 5.5 hours, miles per hour, which is about 68.18 miles per hour. Since we want y equals mx plus b, the next thing that we need is our b value. So our initial value is considered our y-intercept, right? Where we started from. It's where we started. Well, it started 5 miles outside of Albuquerque based on the problem description. So that is going to be my b, right? So b will be 5 miles, m will be 68.18 miles per hour, and then I can put that into the form y equals mx plus b to get the equation that y is equal to 68.18x plus 5, and then our output in this case will be miles, and our input will be number of hours. Another form for equations to take is called point-slope form. This form is easiest when you have a point and a slope already defined. So you have a point, some x1, y1, and you have a slope, what your m value already given to you, and then you can just substitute it into point-slope form in order to get your equation for your line. That form comes as y minus y1 equal to m times x minus x1. From this, now if you recall how we calculated slope earlier, we took the difference in our y values, right, over the difference in our x values. So this is just a generalization of that exact concept. Any xy that is on the line that I substitute in will ensure that I get my slope out, right? That was one of the things we talked about for what lines are. Lines have a constant slope, right? That constant rate of change. So these two forms are directly related through how you calculate slope, because that's really all it is using this equation that we have here, there it is, a color, right? Take this equation, and then if you multiply both sides by that x2 minus x1 term, you get what looks like point-slope form, just with specific values substituted in here instead of a generalized x and y value. So let's try another example, again with the trains. If we have a train that's traveling 80 miles per hour and passes through Littleton, 300 miles into its travel, on hour 3 of its journey determine a linear model for the distance it has traveled. So again, y will be the distance traveled. The distance traveled in our data point is 300 miles. The input in this case, right, since we have miles and we have hours and we have miles per hour, clearly the input in this case will be hours. So hour 3, 300 miles away. And then the rate, which corresponds to our m value, is given by the 80 miles per hour. Anytime it's something per something, it's probably a rate. So since the speed is our rate of travel, that will be our m value. Our distance, as I said, right, that's the y, and our time is our x. So when we construct this model, m will be given by the 80 miles per hour, y1 is going to be 300 miles, and x1 will be 3 hours. Then you just substitute it directly in to point slope form, okay? The m goes right where it would go. The y1 goes in the subtracting point, right, y minus y1, and then x1 goes into the side where the x is. From here, you can convert it to slope-intercept form if you would like to, just to make a little bit more sense in the context of how you're used to thinking about lines. So you can solve it, right? We have y minus 300 is equal to 80x minus 240x if you distribute that 80. First thing that you would do here to solve, right, if I'm solving for y equals mx plus b, I want to isolate y. So I would add 300 to both sides first, and that reduces it to 80x plus 60. That looks just like slope-intercept form, slope being 80 and intercept being 60. It's important to take a moment to think about some odd cases for lines. Most lines that you see are at some sort of an angle with the axis or the axes. But what happens if your slope is 0, for example, right? What if m is 0? You now have no rise over run. Which means that rise must be 0 for any run, because otherwise, because you don't want to divide by 0. So clearly the rise is the thing that is not happening. There is no rise. So that corresponds to a flat or a horizontal line. And then here's just a little sketch, right? If y equaled 1, for example, it might look like the picture here. Alternatively, what happens if m approaches infinity? It's going to be exactly rotated 90 degrees. So you get a vertical line as your slope approaches infinity. And a vertical line is usually given by something that has no y's, because it doesn't have anything to do with y. It's actually a fixed value of x. So an example of that might be, what if x equals 2? And then there's a sketch here to represent the form that you would see. So a horizontal line has no rise at all, and that corresponds to it's parallel to the x-axis. We'll talk more about parallel in the next section. Whereas a vertical line is going to be parallel to the y-axis, and is not going to have any y's in the equation. So the horizontal line has no x's, the vertical line has no y's. The last part from this section is just talking about the general form for the equation of a line, right? You're very comfortable with y equals mx plus b, I hope, at this point, because that is pretty much what you've been using for a very long time. But that's not the only way the line can be, right? I just showed you, what if y equals 1 or x equals 2? Those aren't y equals mx plus b. Well, I guess they are, but they're not just y equals mx plus b. They're a specified case of y equals mx plus b. So any equation that just has an x or a y and or a constant is going to give you a line, right? So no x squared, no y squared, no 1 over x, nothing like that. Just x on its own, y on its own, and or a constant. Any combination of 2 or all 3 will get you a line. So an example, basically I'm just going to ask you, is x equals negative 3 a line? Yes, it is. The reason that it is, right, is this is if x equals -3, that's a vertical line, but it's still a line. What about 3y equals 1? Is that a line? Yeah, y equals 1/3. That sounds a lot like a line that you had earlier, right? That corresponds to a horizontal line. Okay, what if y equals 2y? That one is not going to be a line. The reason is because in this case, if I divided both sides by y, I'd effectively have 1 equals 2. Does that even happen? No. It corresponds to the point when y equals 0, but under no other circumstances is this equation going to be satisfied. So that is not a line. That's just one value. What about x equals 2y? Yes. In this case, we have an x and we have a y. There's no x squared or 1 over x or anything like that. So yeah, we have an x and we have a y. That's going to be a line. What about 3x minus 4y equal to 5? We have an x, we have a y, we have a constant. We have all three of the things and nothing extra here. So yes, this is also a line. Okay? In order to graph these weird ones, the best way to do it, there's two options for you here. You can convert the equation to look like y equals mx plus b, which basically means solve for y, and then use the form that you have compared with y equals mx plus b in order to graph the line, because you'll know the slope and you'll know the y-intercept. The alternative to that, which we'll delve into a little more deeply, is finding 2 points on the line by choosing x values and solving for the y values that correspond to those x values. So, right, that's building your table, x, y, and so for this last one, the 3x minus 4y equals 5, I can solve for y, or I could just pick x values. So if I picked x is equal to -2, then I could substitute that in. 3 times -2 minus 4y is equal to 5. So what is y? That's a -6, so I'm going to add 6 to both sides. -4y is then going to be 11, and then I divide by the -4. Now I have -11 over 4 for my y value. Once you have 2 points, so let me try 0, because that sounds like an easy one. Then I have 3 times 0 minus 4y is equal to 5. So this is just 0, but if I divide by the -4, then I'm going to have -5/4 for my other point. And then you can go to your axes and sketch the 2 points, and then just use a ruler to draw the line. That's all you need in terms of plotting it. We'll do more in class. Let me know if you have questions.